Okay, guys, welcome. This is Harry Lungu, and we will be answering tutorial sheet 1 of MSM 111. So, this is the first question which we've been given. Universal set is -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Then X is a set of even numbers. Then Y is a set of prime numbers in U, the universal. Then Z is -2, 3, 5, and 6. Perform the following. So we will start by listing these sets which are not given. We've just been, if you watch the previous video, this is one way of listing sets, or of describing sets. This is the listing method. And we also have the rule method, where you are just given the rules. Okay, so we start with X. So let us list set X. So set X is equal to the set of all even numbers. Now, we want to list set X if we don't know what even numbers are. So what are even numbers? Even numbers, or an even number, is any integer which can be divided by 2 without leaving any remainder. So if you look at the universal, you have -2. By the way, 0 is also an even number. So you have -2, 0, 2, 4, 6. So these are only these numbers can be divided by 2 without leaving a remainder. So let us list them. So you have -2, we have 0, we have 2, we have 4, we have 6. Okay, then we have, so this is our set X, and then we have set Y. Y is a set of prime numbers. So what are prime numbers? Prime numbers are numbers greater than 1 which cannot be divided by 2, so without leaving a remainder. So these are just the opposite of even numbers. So we are saying they are greater than 1. So meaning 2 is a prime number, 3 is a prime number, 5 is a prime number, and we have 7 here as our prime number. Then we've got Z, which has been listed for us, which is -2, 3, 5, and 6. So these are our sets. Now let's perform some operations. So we have 1. We've been told to list X union Y. So X union Y, they want us to combine X and Y without uh, repeating the same elements which are in X and Y. So here we'll list X first, which is -2, 0, 2, 4, and 6. Then we unionize it with Y, which is 2, 3, 5, and 7. Okay, so X union Y is the combination of the two. So we have -2 here, -2, we have 0, we have 2, we have 3, we have 4, we have 5, 6, and 7. So this is our answer for the first question. Okay, so we go on the second question, which is X intersection Y complement. X intersection Y complement. So there are two ways which we can use to answer this question. So the first way is finding X intersection Y and then removing those elements in X intersection Y, removing them from the universal. Yes, so we can start by listing the universal first. So the universal is -2, -1, 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so we can list x intersection y. We list x intersection y. That is, if we list x which is negative 2, 0, 2, 4, 6. Okay, and then intersection y which is 2, 3, 5, and 7. So let us find what is common. So we have 2 in here, we have 2 in here. Okay, so only 2 is common here. Only 2 is common. So x, okay, so the only number, the only element which is common between x and y is uh, is 2. Okay, so we have 2 here. We have 2 here. Now they said complement, so meaning in the universal you are going to remove only 2, only that which is common, meaning what is common complement. So meaning the universal you remove 2. So x intersection y complement is equal to and listing all these, just removing 2 which is common. So we have negative 2, we have negative 1. Okay, we have 0, we have 1, we have 3, 4, 5, 6, and 7. Okay, so this becomes our answer for the second question. Okay, okay. So we go to the third question, which is x intersection y slash z. Okay, we go on question 3. Question 3, question 3, which is x intersection y slash z. So this is the same as x intersection y intersection z complement, which is equal to x intersection um, uh, y minus z. Okay, so you can either choose to answer it using this method or this method, but I think this one is easier, whereby we'll subtract all the elements that are in z, all the elements which are in z, all the elements of z which are found in y, we'll remove them, and then whatever will remain in y, we intersect them with x. So let us find first, let us deal with the one which is in brackets. You know, at secondary we were taught to use board mass, So I'll use board mass as well. I will start with what is in the brackets. So I will find y minus z first. So meaning y, if I list y, which is 2, 3, 5, and 7. Okay, and 7, then minus, okay, z, which is negative 2, 3, 5, and 6. Okay, so if you don't understand what is being done here, refer to the previous video which I made. I explained this. So when you see something like y slash z, is simply they are simply asking you to subtract y, I mean to subtract z from y. So y minus z in this case will be equal to 2 comma 7. What have I done? They want me to subtract z from y, so the elements which are in here, which are in z, I remove them from here, and then I remain with 2 and 7. Okay, now I have to intersect this. Now x intersection y slash z is same as getting x, which is negative 2, 0, 2, 4, 6, intersecting it with 2 comma 7. Okay, so what is common here is just 2. Okay, so x intersection y slash z is equal to 2. Okay, is equal to 2. So this is our answer. And then the fourth question, which is the cardinality. The cardinality of, if you can see here, they're asking us to find the cardinality of x union y. So x union y, the cardinality of x union y, which can be represented at n open bracket x union y is equal to, they are simply asking you for the number of elements in x union y, and we found x union y to be equal to this here. So when they say x union y, the cardinality of x union y, they simply asking you to find the number of elements. So you just have to count 1, 2, 3, 4, 5, 6, 7, 8. So you write the cardinality of x union y is equal to 8. Okay, so these are the answers for question 1 in MSM 112 tutorial sheet 1. Yeah. Okay, so let us go to question 2. So question 2 reads, let x, we have square brackets 0, 10. So be the universal set of be the universal set, and a square bracket 1, 4, b curved bracket 2, 8, and the c square bracket 3, 6, and then we close with a curved bracket. Be the subsets of x. Find each of the following and display them on the number line. So we have okay, so let's find the solutions here. Okay, all right. Okay, so what we do here, we are dealing with real numbers. It's a bit different from the previous question. Here we are dealing with real numbers. Those numbers were whole numbers, but here we deal with real numbers, meaning we'll have decimals, we'll have decimal numbers as well. So if we have to represent whatever we've been given, uh, uh, in the question, okay. Okay, apologies. I had to cut the previous video, but let us continue. Okay, so let us represent whatever we've been given, uh, whatever information. Let us illustrate it on the number line like this. So we have our number line. I won't draw it to scale, and I'm using. I'll draw them using a freehand. So you have 0 and 10 here. So we'll start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so okay, so um allow me to just write this, because I haven't drawn it properly. Okay, so let me draw it somewhere here where I'll have space, because I have to write something on top. Okay, so okay, here. Okay, uh okay, like this. Then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 here. Okay, then we've been told that a is equal to 1, 4. So we have a here. So you have to you have to close 1, 4. Okay, and then you draw like this, you connect. So meaning this is our a. Then we have our b to be 2, 8. So if you see those brackets, we have to leave them open. So we'll have open, meaning we have 2 here, and where there is 8 somewhere here, we leave them open like this. Okay, so this will be your b. And then we have c. C as a square bracket, meaning one side has to be closed, one side has to be open. So our C will be 3 here will be closed, 3 here will be closed, and 6 here will be open. Okay, something like this. So we have our C here. So, and then they ask us to say, find B complement. So B complement is anything that is not in B. So anything that is not in B, so this will be B complement. So meaning we have to shade here up to here, even somewhere here, up to 10 here, like this. So this is okay. Sorry. Like this. So this is our B complement because we are interested in anything that is outside B. Okay, and you know that B is this. So whatever is outside B is our B complement. So we are going to say B complement is 0, comma 2 close union, okay, 8, comma 10. So this is our answer. Now they have said show it on the number line, display it on the number line. So meaning you don't have to end here, you have to draw it. So you have to draw a new number line now, okay, like this. Okay, so you have to draw. All right, so this will be your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so you have to draw here to show that this is your B, this is your B complement. So even 2 here you draw, even 8 here, even somewhere here you draw. Okay, so then you are done for question 1. So for question B, they have asked us to find A intersection B. A intersection B. Okay, so A intersection B is anywhere where A and B are meeting. So it is this region here, this region, this region. So A intersection B will be equal to, now if you see 2 here, 2 is included in A, but it is not in B. So meaning when writing your answer, you don't have to use square brackets because 2 is not included in A. It is not included in B, it's only in A, but we want what is both in A and B. So you write 2, comma, okay. So 4 is included in both B and A. So this one will be like this. Okay. So the answer hasn't ended, so we have to display it on the number line. So we are going to do it like this. Okay. Okay. Like this. So you're going to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you're going to uh, leave it open here, but on 4 you are going to shade because 4 is included in both A and B. Okay, then you are done for this one. Okay, so we go on A intersection B complement, A intersection B complement. So A intersection B complement, we don't have to struggle much because we have A intersection B. And then when they say A intersection B complement, they just want everything outside B. So what you can just do, you can just say A intersection B will be equal to 0, comma, because they want everything outside this, So it's 0, comma. Now when writing 2 here, we have to include it because it is not included here. So in the complement it has to be included. So we are going to use this type of bracket. Then union here 4 is included, so we don't have to include it. Okay, so I'm going to use these kinds of brackets. 4, comma 10. Okay, so 10 has to be included. Now they say and display them on the number line. So when displaying you do this. Okay. So we're going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you're going to write, you're going to shade here, you also shade here, boom. Then here you have to leave it open, then you shade on 10 here, and then you write like this. Okay, so we go to the fourth question, which is um, um number 4. We've been given something like a intersection b minus c complement. Okay, so this one, uh um how we will do it will be like, let us modify it a bit. So we are going to say a intersection b intersection c complement intersection. Now this intersection, you have to distribute it, the one which is outside. So it will be a intersection b, according to De Morgan's law. When we distribute this, it will be b complement. This sign will change to union, and then this complement and this complement will cancel each other. So we have something like this. So meaning you have to find, we have to intersect first. You have to find what is in the bracket first. So b complement union c, b complement union c. If we look at our, if you look at our number line here, we have b complement as this. Then you have to unionize it with c. So we will start with finding b complement union c before we deal with a there. So it will be equal to a, it will be equal to what is b complement? We have 0, 2 here. Okay, union 8, 10. Okay, you have something like this, and then this is just b. Okay, I've included these brackets to show that this is just b. Then unionize it with what? Unionize it with c. C is 3, 6. Okay, so how do we now unionize these two? Okay, so to make it easier for you, you will okay, so here you just leave it like this. You have unionized b complement union c, so you have unionized it, but we have a intersection b open bracket complement union and c here. Okay, so what we'll do here is that we'll bring a. So when we look at the illustration of the information we've been given, let us represent first this thing here, this thing on a number line. So let us draw it first. Okay, so it will help us to answer this question fast. So we drew 0, 1, 2, 3, 4, 5. Don't worry, you don't have to draw this to scale. 6, 7, 8, 9, and 10. So if we represent this, we have something like 0 here, 2. Okay, boom. Then we have this c, which is 3, 6. Then we have 3, 6 here, boom, like this. Okay, this is our c. Then you have we still have b complement here, which is like this. Moreover, this is open, it's not closed. Then you have 10 here, boom. And then they say intersection a, so we have to draw a and see where these guys are intersecting, if there is any. So we have a. If we look at a there, if we look at a, we have 1, 4. So you have to draw here, we have to draw here 1 and 4. Our a is here, our a is here. So when you draw, you find that these guys are intersecting at this point, at this point, at 1, 2, and 3, 4. So meaning the answer to this question will be equal to A intersection B complement union C to be equal to 1, 2, okay, union 3, 4. Okay, okay. So we have to represent this now on a number line again. Then we'll be done. Okay. All right. So we draw like this. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, like this, and then we draw like this. We'll draw 1, 2, 1, this, and then we have a 3, 4, 3, 4. Then boom, we are done. So thank you very much, guys. See you in the next video. This is Harry Lungo. Don't forget to hit the like button and subscribe to my YouTube channel. Shalom, shalom.